Today I'm going to talk about Gödel's incompleteness theorem. The theorem is about what math is able to do, and it says that math can't do everything, that there are some mathematical statements that are true, but impossible to prove. But how did Gödel manage to prove this limitation on math? Well, imagine you are creating a new language, with all sorts of specific letters and words, but you have to be very careful about the way your language is used. This is a language of truth. You're not allowed to write any false statements in your language. It has specific rules for combining true sentences to prove other true sentences, infinitely many of them. The sentences can mean anything. They could say, peaches are just fuzzy nectarines, or snails don't have antlers. It's not really important what they say as long as they are true, which they are if you follow the rules. But does our language have a sentence for every true statement? Are there any true statements that the language is unable to prove? Gödel thought about this, but first he asked an interesting question. Can these sentences talk about other sentences? It seems unlikely because our language is a very carefully closed system. It doesn't allow for any loopy logic like the famous liar paradox. But Gödel did a clever thing, which was to create a system for labeling each sentence with a word in the language. Once he did this, he was able to use the language to talk about itself. A given sentence will now have its usual meaning, but in addition, it can describe other sentences. For example, it might say, the sentence with this symbol has 3 words, which is pretty cool. But what Gödel did next was even cooler. Using some very clever logic, he was able to construct a sentence that said, the sentence with this symbol cannot be proved. But he constructed the sentence in such a way that its own symbol was the one being talked about. So the sentence really means, I cannot be proved. Whoa, what does this mean? How do we even know the sentence is true? Well, if it's false, then its opposite must be true, right? Its opposite is the sentence with this symbol can be proved, but this symbol still refers to the original sentence. Therefore, the new sentence is only saying that its opposite can be proved, which leads us down a nasty paradox. So to avoid the paradox, the original sentence must be true, which means that our language can't prove everything. There are some sentences that our language just can't confirm. It is incomplete. Gödel did this same thing but with the language of math, and was able to prove that math is incomplete. There are some theorems in math that are true but are impossible to prove. Maybe it's the twin primes problem. Maybe it's the Goldbach conjecture. It doesn't really matter what they are. What matters here is that these unprovable theorems do exist, which is an incredible limitation on such a seemingly powerful system like math. It implies that the mathematical truths of the universe cannot be proved only by symbols on paper, but must be determined outside of math, using human reasoning.